All right, all of those calculations that I told you previously probably sounded a little bit confusing to you. This is much, much easier if we use what we call a VIR chart. V meaning voltage, I meaning current, R meaning resistance. And this kind of makes it like a puzzle, a really, really easy puzzle that you just have to solve. So to make a VIR chart, it's just a table with VIR across the top, again, voltage, current, resistance. And then across the left side, down the left side, we're going to list simply however many resistors there are. There's 3 in this case. And then at the bottom, there needs to be a total. So you need to have one more row than you have resistors. So R1, R2, R3, and then a row for total. All right. So this is how we start to set it up. The first step after setting it up is you can actually fill in a lot of information here without doing any thinking, any math. So the first thing we can do actually is simply plug in the resistances of the resistors. R1 is 10, R2 is 20, R3 is 10. So we're simply going to enter those in that column. If you need to, pause the video real quick, set this up on your own paper. All right, so and you'll need to set these up on your own as we go, obviously. The next thing you can do after that, again, no thinking involved, is put in 10 volts for the battery voltage. This one down here for both series and parallel circuits that we haven't gotten to yet, the battery voltage is going to go right there. So all I got to do is look at my battery voltage, 10 volts, boom, it goes there. So we've already done quite a bit of this without even doing any math at all. Fairly simple to set up. And then from here, there's a series of steps to take. The beautiful thing about this chart is that usually you can fill in, you can look across the rows and down the columns, and you can usually, if you have all but one of the numbers, you can fill in that one using Ohm's law or something else that we've talked about already. So what we're going to do next is fill in the total resistance. Total resistance for series is really simple. Remember, we just said we add them up, and we came up with 40 before. This is the example that we've already done. Next, I'm going to look at this row right here. Notice that we have 2 of the 3 numbers. I can get the third one using Ohm's law, I equals V over R. And again, we've already done that. Voltage divided by resistance, 10 divided by 40 is 0.25. Now, here's the beauty in series. Remember, we said that current was the same in series because there's only one path. So that means once I get this current, all I have to do is zip it up the top because it's 0.25 amps everywhere else. So only in series, not in parallel, we'll get there soon. In series, the current is always going to be the same from the bottom to the top, should be the same number. All right, and now if we look again, all we have left is our V's, our voltages. Again, Ohm's law says V equals I times R. We can think of this chart that way. So all we're going to do is go across each row and multiply our current and our resistance. On the top, R1, 0.25 times 10 is 2.5. 0.25 times 20 is 5. 0.25 times 10 is 2.5. Again, we've already done all of these calculations before. Now, we've got all this filled in, but let's just check it to make sure it's right. Several things that you want to look at to be able to check. First thing you want to look at in a series circuit, you want to check that the total resistance is the highest number in the entire column because the resistances simply add up to calculate the total resistance. And that is the case here. You also want to check the second column. The current should all be the same, and that number should be very low. We'll talk about that in a few minutes. But it should be a really low number, and it should all be the same. It should match up to what it was down here. And the third check, the voltages should almost add up to the total. I will tell you, depending on how you rounded, sometimes you might find that they don't quite exactly round up to the battery or add up to the battery voltage. It'll come close. But again, that's just because of rounding, not necessarily because you made a mistake. So that's how we know that this one's good. Now, before we move on and do some more practice circuits, and that'll be another video, what I actually want to do is just talk to you about a few more really important notes to know about series circuits. So one of the important things that you need to understand about a series circuit is because there's only one pathway, series circuits inherently always have high resistance. Notice the total resistance was 40 on this one, and they have low currents. So you need to know this. You need to know that series circuits are always going to be higher resistance, lower current circuits. That's because resistances add up. So as we add more resistors, that total resistance is going to increase, which drives down the current. Current goes down. Second thing you need to know about Series circuits, again, because there's only one pathway, that means they're vulnerable to failures. If there's any break anywhere in the circuit, if anything fails, it results in complete failure. And these two characteristics mean that series circuits are really of very limited use. Doesn't mean we don't use them at all, but they're only going to be used in very specific applications where we need very low current, or if a complete shutdown with any failure is desirable. Like if something fails and we don't want the rest of the circuit running because that thing has failed, then a series circuit might be appropriate then. But even at that, there's other ways to make that happen other than a series circuit. So basically, series circuits are of very, very limited use for us. All right, we'll go ahead and put it in this video. Let's go ahead and look at two more practice circuits. So here's what I want you to do first. Imagine that you connect two light bulbs with individual resistances of 15 ohms and 12 ohms respectively in series with a 6-volt battery. First thing I want you to do, if you can picture this circuit in your mind, I just want you to draw it. Take a look at the circuit diagrams that I've given you before. Simply draw the circuit diagram. Pause the video now and draw it on your own piece of paper. All right, hopefully if you draw the circuit, you will get something like this. Now, let me tell you this. It really does not matter where you put these. Don't erase your circuit. You can put them on the sides. You can put them both. You can put them top and bottom. It doesn't really matter as long as, series circuit, there's only one pathway from the negative terminal through those two resistors back around to the positive. That's all I really care about. And take note of this. Your circuit diagram is not complete if you do not have three things. Label the battery voltage, label the resistances of all the resistors, and number the resistors, R1, R2, R3, however many you have. All right, now the next thing we want to do to analyze this circuit, we're going to use our good old VIR chart again. So all I'm going to ask you to do is complete a VIR chart for this circuit. So go ahead and draw this chart in your notes. See if you can remember what we did before. Go ahead and complete this chart like a puzzle. Pause the video now and see if you can do it. All right, so remember, we start out with no thinking, no math involved. We plug in the resistances, 15 and 12 in this case, and we plug in the battery voltage, 6 volts. Haven't even done any thinking yet. Next step, we're going to do the total resistance. 15 plus 12 is 27. The next step, I'm going to do the total current because I have two of the three things in this row. Remember, to get current, it's Ohm's law, V divided by R. I equals V over R. 6 divided by 27 gives me 0.2. And again, in series, it's 0.2 all the way up because in series, current is always the same. Now we're going to multiply I times R across each row to get the voltage, and we get 3 on the first one, 0.2 times 15, 2.4 on R2, 0.2 times 12. Now we do our check. This one should be the highest, and it is. These three should all be the same and pretty low, and they are. And these two should add up to the total, but wait a second. 3 plus 2.4 is actually 5.4, and that's not exactly 6. Well, the reason for that is rounding here. So it turns out, and you probably did this yourself, actually, if we go back and we do 6 divided by 27, you actually get 0.22 here. So if we put 0.22 on all these numbers get a little bit closer. So again, it's really about rounding. As long as we're fairly close, we're going to be okay here. Let's do another circuit. All right, here's the circuit right here. You should have a better idea about how to do this now. Go ahead and pause the video and complete this VIR chart for this circuit. All right, here we go. 3 resistors on this one, 20, 10, and 20. The battery voltage is 6. We do the total resistance by adding the resistors, and we get 50. Next, we do the total current by voltage. It's doing voltage divided by resistance. 6 divided by 50 is 0.12. And again, 0.12 zips all the way up because current is the same in series. And the last step is to multiply across each row current times resistance to get each voltage drop, 2.4, 1.2, and 2.4. And if we check here, these actually add up exactly to 6 volts. So we're good there. So that's how to analyze series circuits.